Hey guys, how's it going? Hope everybody's doing well. Doing another live stream this week. Happy Pi Day. Today's Pi Day. I don't know if all of you were aware of that, but March 14th, 3/14, it's Pi Day. So today I'm going to be going over some product rule examples. I wanted to show you, really when it comes to product rule and finding the derivative of a function using product rule, there is a very easy process to go through when you're doing those types of problems. So I wanted to show you how you can make basically any product rule problem super, super easy. And so I'm going to be going over that process with you. This is going to involve the product rule formula. And so part of this process that I'm going to explain is an easy way to remember the product rule formula, as well as the easy way to apply the product rule formula. So by the end of this video, you should be a lot more comfortable with product rule formula, how to apply it, how to find the derivative. Let's go ahead and jump into the first example here. So and just realize you can kind of see the next example a little bit ahead, but that's okay. Well, actually, let me just see if I can scoot that over a little bit real quick. Sorry. Did not realize that was going to be visible from over here. All right, here we go. So let's go ahead and kick this off. First of all, we're going to find the derivative of y equals, in parentheses, r squared minus 2r, close parenthesis, times e to the r. So you can see pretty clearly here, looking at this example, we do have a product, right? We have kind of these two different chunks of this function that we're going to be taking the derivative of that are being multiplied together. So that is obviously the first condition that we need in order to apply the product rule. So to apply the product rule, really that's going to be applicable whenever you have some function that can be thought of as the product of two smaller, simpler chunks of that function, which we do have here. So one thing to kind of note here, obviously within the parentheses here, we have one thing minus another thing. But since this whole, this whole thing right here is all in parentheses being multiplied by something else, we want to think of this whole parentheses as one of the parts of the product. So as a result, we can use the product rule to find the derivative of this function. There are other ways we could find the derivative, but I really want to go over product rule here. So this is going to be kind of the method we're going to apply. We can just leave it in this form in order to apply the product rule. So first of all, the product rule says that if we're trying to find the derivative of two functions being multiplied together, so let's say we want to find the derivative of f times g, that derivative would just be, and this is, just the formula. I'm going to show you, like I said, kind of the method that you can go through so that you don't really have to memorize the formula necessarily. But just so you have it, it's going to be the first term times the derivative of the second plus the derivative of the first times the second left alone. So f times g prime plus f prime times g. You could see this in other forms. We could switch this piece with this piece so that we have f prime times g plus f times g prime. It doesn't matter. That's the same thing, right? 1 plus 2 is the same as 2 plus 1. You could switch them. So, there are a lot of different orders we could write this, but the important thing is that the non-derivative of one function is being multiplied by the derivative of the other one, f times g prime. And then same thing over here, the derivative times the non-derivative. So, like I said, kind of the way that you want to think about these product rule problems, if we can ignore the formula for a second and let's just think about what process we want to go through. So I've already kind of pointed out that we're going to say we have the product of these two things here, r squared minus 2r being one of those things, and e to the r being the other thing. Okay, so if we're going to take the derivative of this function, we want to break it down into the two pieces that you are taking the product of to get your original function. So in this case, r squared minus 2r being one of those, e to the r being the other. So basically what we want to do then is call one of those f and one of those g. It doesn't really matter which is which, right? We could call this f and this g, or we could call this f and this g. that's what's kind of nice about the product rule, is it's going to end up working out right either way. So let's go ahead and just say that r squared minus 2r is f, e to the r is g. Okay, so that's step one, is designating which thing you're going to call f, which thing you're going to call g. Once you do that, the next step is to take the derivative of each of those things. So first of all, the derivative of r squared minus 2r, we could find just using the power rule. So we're just going to move the 2 down in front, keep the base of r the same, and then lower the power by 1. Lowering 2 minus 1 is just 1. So the derivative of r squared is 2r. And then the derivative of a constant times your variable is just going to be whatever that constant is, so 2. Then we need to find the derivative of e to the r. Well, in this case, r is our variable. So I guess I shouldn't have said d dx. Let's think of this as d dr, because that's really what we're finding here. We're treating r as our variable instead of x. So the derivative of e to whatever your variable is, the derivative of e to the r in this case, is just e to the r, right? E to your variable, specifically this base e, which is like roughly 2.71, is a very unique function because it is its own derivative. So as a result, g and g prime are both going to be e to the r. Okay, so now once you have found these 4 things, or decided your f and your g, and then found your f prime and your g prime, applying product rule is super easy. Okay, all you have to do, once you have f, g, f prime, g prime, multiply across. So you're going to do like a crisscross multiplication here, and then add up those 2 products. So basically this thing times this thing. So r squared minus 2r times e to the r times this thing here, and then add this thing times this thing. So 2r minus 2 times e to the r. Whoops, not times r, sorry, times e to the r. Okay, so you just multiply them across to get these 2 different products here, and then add them together. And then from here, we could simplify this a bit. So one thing that's kind of interesting here, both this term and this term have an e to the r in common. So what we could actually do is factor out e to the r and be left with each of these other 2 things. And then we can, in this case, the parentheses aren't really doing anything. We can drop the parentheses and combine our like terms. Basically, that's going to cancel with that, and we're just going to get r squared minus 2 times e to the r. So this is going to be y prime, which is the derivative of this original function up here, r squared minus 2r times e to the r. Actually, wait a second. Did I make a mistake somewhere? No? All right. Cool. I'm not seeing any questions in the live chat. As always with these live streams, if you do have questions along the way, you're always welcome to drop them in the chat, and I'll do my best to answer whatever questions you have. But anyways, man, I don't know why this looks wrong for some reason. I don't think it is. I don't see any mistake anywhere along the way. But we'll go on to the next problem here. All right. So product rule example number 2 here. We're going to differentiate z equals w to the 3/2 times w plus c e to the w within parentheses. So important thing to point out here, in this case, w is our variable, And then this c here is a constant, some unknown constant. So as a result of the fact that we don't know what that constant c is, it's completely possible that our answer is going to have a c in it somewhere as well. But we do want to treat w as our variable here, and then z is the function instead of y. And then, w is basically the variable instead of x, like you would commonly see. But either way, the process is exactly the same. So just like we did in the last example, and like I said, product rule is one of the topics covered on my Calculus 1 study guide and my complete Calculus 1 package. The links to both of those are down in the description. Go check those out. They're all available instantly for instant download, so you can start using them right away if you'd like. But the first step in doing these product rule problems is to first decide which thing you want to be your f, which thing you want to be your g. And like I said, it doesn't matter which thing you pick as long as you're making sure that the f and the g are the two things that are being multiplied together. So in this case, we have our multiplication, our product right here, where we would have this being one of the product terms and this being the other product term. So basically, as long as we're calling either f or g w to the 2/3, or to the 3/2, I'm sorry, and the other being w plus ce to the w, we should be good. So we can just say w to the 3/2 here and w plus ce to the w here. Now, the next step, once you have decided on your f and your g, is to find f prime and g prime. So to find the derivative of w to the 3/2, we can do power rule. Again, we'll bring our power down in front, giving us 3/2 here, keep our w as w, and then subtract 1 from the power. 3/2 minus 1 is the same as 3/2 minus 2/2, which is the same as 1/2. So this new power is going to be 1/2. And then the derivative of this, the derivative of w, the derivative of your variable by itself, is always just going to be 1. And then, kind of like we ran into in the last example, the derivative of e to the x or e to the w is just e to the w, right? And whenever you have a constant times some function, the derivative of a constant times a function is the same as that same constant times the derivative of the function. So as a result, the c coefficient is just going to carry through, and then the derivative of e to the w is just e to the w. So the derivative of c e to the w is just c e to the w. Okay. Now, once we have figured out f, g, f prime, g prime, all you have to do is multiply across. Do a little like x switch multiplication where you do the derivative of one times the original of the other, derivative of one times the original of the other. So we're going to get w to the 3/2 times 1 plus c e to the w. Now, it is important when you're doing this w times all this stuff, this term here, you want to put all these in parentheses. So treat them all as if they're in parentheses when you multiply them with each other. So we could do this as well. In that case, since it's only one term, there's no addition within there, it doesn't make a difference. But if it helps you to always remember the parentheses, in cases where it would need to distribute, like it may have to here, I would just recommend putting parentheses around all those. Okay, so we've done this one times this one. Now we need to do the derivative of this one times the original of the other. So we'll do 3/2 w to the 1/2 times all this right here, w plus c e to the w. Okay, and then once we've done our two, across multiplying, then we just add these two things together. Just throw a plus sign in there. Okay, so now from here, what we could do is we could distribute all this and then simplify from there. What we could do instead, though, which may make things a little bit nicer, it probably isn't really going to make too much of a difference, actually. Yeah, I don't think it really will make that big of a difference. But what we can do is both of these have a w to the 1/2 in common. So we could actually factor out w to the 1/2 from this. If we took a w to the 1/2 out of this term, we would be left with just w. Because if you have two things with the same base multiplying together, you would just add their powers. 1/2 plus 1 is 3/2. So we would have W times 1 plus C, that was sloppy, C times E to the W. And then plus, if we pull a W to the 1/2 out of here, we just have 3/2 times W plus CE to the W. Okay. Now from here, we could distribute these in here. So distribute the W in there, distribute the 3/2 in there. And keep in mind, this is all Z prime, right? Our original function was Z, so this is all Z prime. So W to the 1/2, distribute our W in there, plus CW E to the W, plus distribute our 3/2. So we get 3/2 W plus 3/2 C E to the W. And then there isn't really any more simplifying we can do here. There's nothing that these all have in common. We don't have any like terms. Actually, yeah, we do. Sorry. Yeah, we definitely have like terms here. So first of all, we have a W plus a 3/2 W. So those could combine into a 5/2 W. And then CW to the EW, 3/2 C, these aren't going to be able to combine, right? This one has a W, this one doesn't. Those aren't going to nicely combine. So we're just going to be left with each of those being added in here as well. And then we still have our W to the 1/2 out here. And that's going to be our derivative. Doesn't look like there's going to be any more simplifying we can do there that's going to make things really any nicer for us. So we'll go ahead and leave it right there. All right, perfect. Next example here. Let's go ahead and move on to the last one we have here. So we are going to differentiate G of t equals t minus the square root of t all over t to the 1/3. So here's the thing. You're probably looking at this and thinking, product rule does not apply there. What the heck are you talking about? There's no product. And you're right. But there is a trick we can apply here in order to use the product rule. And I know that seems weird. I mean, looking at this, clearly there's division, right? We have this fraction where we have this top function and bottom function. Quotient rule probably makes more sense here, right? Well, you definitely could use quotient rule. You would definitely be right about that. However, there's a way we can use product rule instead. Now, like I said, quotient rule would definitely work. If you're comfortable with quotient rule and you want to use it, do it. But we can also use this exact same example to get practice with product rule instead. And what you would find is you would actually end up getting the exact same thing. However, there is an important step we need to take before applying product rule because we don't have a product as it is right now. We have to do some rearranging, right? Because like I've been saying, in order to apply product rule, you need to have one function times another function. Well, we don't have that. But let's think about how we could rewrite this fraction to, instead of having division, have multiplication. Well, that's going to come into play based on our denominator right here. So what we want to think about is, how could we rewrite this fraction so that there is no division and instead multiplication? Well, in general, if you ever have a fraction like this, if you ever have your denominator like this, you can move something out of a denominator up into the numerator of fraction by making the power negative. If the power already is negative, you just make it negative, which turns it into a positive, right? So instead of writing this as t minus the square root of t divided by t to the 1/3, we can rewrite this as t to the negative 1/3 times t minus the square root of t. Okay, and make sure you put the t minus root t in parentheses, because this would need to be distributed in and multiplied by both of these terms. Just like up here, it's dividing both of those terms by t to the 1/3. So these two things are actually equivalent. This g of t is exactly the same as this g of t. There's no difference. And now notice, when we look at this, we do have a product. We have this term being multiplied by this thing here. So what we can do is we can say f equals t to the negative 1/3. And I'm going to use, I know the product rule formula that you typically see has f and g, but since this function is called g, I don't want there to be any confusion about this g being this different from that g. So I'm going to say we're going to use f and h instead. So it's the exact same idea for using the product rule formula, except I've substituted g out for h. Same idea though, okay? We're still going to go through the exact same steps. So this still is going to be applicable to any product rule problem. So what we're going to have is t to the negative 1/3 as f, and then h is going to be all this stuff. So t minus the square root of t, okay? Now, what we can do once we have decided what's f and what's h, we then need to find f prime and h prime. So the derivative of this, we can just use the power rule. Power rule says we bring our power down in front, keep our t, our base, the same, and then subtract 1 from the power. Negative 1/3 minus 1 is the same as negative 1/3 minus 3/3. Negative 1 minus 3 is negative 4 all over 3. So this new power is going to be negative 4/3, not negative 4/4, my bad. Negative 4/3. And then over here, what we actually probably want to do before taking the derivative here is rewriting this square root as t to the 1/2. So anything to the 1/2 power is exactly the same as taking the square root of it. 1/2 power and square root mean the exact same thing. But this is going to be easier to take the derivative of than this, because to take the derivative of t to the 1/2 power, we can just use the power rule. So the derivative of t minus t to the 1/2, the derivative of t is just 1, and then the derivative of t to the 1/2 is just power rule. We bring our power down in front, bring the 1/2 down in front, keep our base t as t, and then subtract 1 from the power. 1/2 minus 1 is negative 1/2. Okay? Now, like we've been doing, once we have figured out our g, our f, our h, our f prime, our h prime, we just multiply across, make an x. So we get t to the negative 1/3 times this one, so 1 minus 1/2 t to the negative 1/2. And then do this one times this one. So we get negative 1/3 t to the negative 4/3 times t minus t to the 1/2. Okay. So notice I did what I kind of mentioned in the prior example here. You want to put each of these things in parentheses, so that when you multiply across, if there's any sort of distributing that needs to be done, you'll remember to do it, thanks to the fact that there's parentheses, okay? And then once you've multiplied across like this, all you do is add a plus sign in there, okay? So this is g prime of t. Now what we can do from here is to go ahead and distribute and simplify. So we can distribute this into both of those terms there, distribute this into both of those terms there. So t to the negative 1/3 times 1 is just t to the negative 1/3 minus 1/2 times t. When you multiply two things with the same base, they both have t as the base in this case, you would add the powers. So negative 1/3 minus 1/2 is the same as negative 2/6 minus 3/6. Negative 2 minus 3 is negative 5/6. So the power is going to be negative 5/6. And then this times t, remember, t is the same as t to the 1. So we add our powers. So we get negative 4/3 plus 1, giving us negative 1/3 t to the negative 1/3. Negative 4/3 plus 1 is negative 1/3. And then this times this term. So negative 1/3 times our negative. So we're going to get plus 1/3 t to the negative 4/3 plus 1/2. Negative 4/3 plus 1/2 is the same as negative 4, not negative 4, sorry, is the same as negative 4, is the same, I'm sorry. Keep on tripping over my words here. We need to turn this into 6. So we're going to multiply this by 2/2. So it's the same as negative 8/6 plus 3/6. Negative 8 plus 3 is negative 5/6. Okay, so now we have a t to the negative 5/6 here and here. We also have a t to the negative 1/3 here and here. So those are going to be able to combine our like terms at this point. So t to the negative 1/3 minus 1/3 t to the negative 1/3 is 2/3 t to the negative 1/3. We just are adding coefficients at this point. And then t to the negative 5/6, t to the negative 5/6, the coefficients are negative 1/2 and positive 1/3. So negative 1/2 plus 1/3 is the same as negative 3/6 plus 2/6 is negative 1/6. So minus 1/6 t to the negative 5/6. So now this is going to be simplified as far as it's going to get, and that's going to be the derivative of this function up here. And like I said, if you were to apply the quotient rule instead of the product rule using the function in this form, you should end up with the exact same derivative as what we got here by doing product rule. So that's all I got for you guys. Like I said, this topic is covered in my Calculus 1 study guide and my complete Calculus 1 package. The link to both of those things is down in the description below. I highly recommend going and checking that out. I think both of them would be a huge help to you. So if you got some use out of this video, please go ahead and hit that like button down below. That's a huge help to my channel. Gets this video out in front of more people and allows me to keep making more videos like this. Well, anyway, thanks, and see you next time.